हेलो फ्रेंड्स, हाउ आर यू। ईटीसी के क्वेश्चंस लेके आए हैं। फर्स्ट क्वेश्चन करते हैं। अच्छे क्वेश्चंस हैं, गेट के प्रैक्टिस वाले क्वेश्चंस हैं। अ वोल्टेज इज अप्लाइड अक्रॉस अ यूनिफॉर्मली डोप्ड सिलिकॉन सैंपल as shown in figure. The electron mobility at x is equal to 0 micrometer is c. कॉन्सेप्ट क्या है इसके पीछे कि फॉर यूनिफॉर्म डोपिंग, फॉर uniform means constant. The doping should be constant. For uniform doping, electric field is constant throughout the semiconductor bar. Throughout the semiconductor bar, the variation of drift velocity and with electric field for most of the semiconductor except gallium arsenide, okay, is, for example, if I draw the graph, this is drift velocity versus electric field. So it will be like this way, okay. So the initial slope of this curves gives the mobility of electrons, like mu n is equal to vd upon e. This is the initial slope of the curve. Now calculation, you have given what? You have given length of semiconductor. This is actually length, okay. This is length is around 1 micrometer. So length of semiconductor is 1 micrometer. Drift velocity of electrons is 10 to the power 4 meter per second. Applied voltage is how much? This is your applied voltage, right? So applied voltage is 2 volt. So electric field is what? Electric field is V upon L, okay. That means applied voltage upon length. So applied voltage is how much? 2 volt, and length is 1 micrometer. So this is around how much? This is 2 volt per micrometer. Now mobility of electrons will be Vd upon E. So Vd is how much? 10 to the power 4, and E, electric field, is how much? Electric field is 2 volts per micrometer. That means it will come out to be as, if it is 2 into 10 to the power 6, then it will be like 1 upon 200. It will be 0.5 into 10 to the power minus 2, and this will be 5 into 10 to the power minus 3. So this will be around 5000, okay, 5000 micrometer square per volt second, okay. So this is like this way, okay, because micrometer square, it is this is the unit of drift velocity, micrometer square per volt per second, okay. Yeah, but it should be 10 to the power 4 into 2. No, 10 to the power, let me check one thing. Let me check if it is wrong. 1 minute, okay. Just rub it. You just calculate it on your own, okay. Like this is Vd is how much? 10 to the power 4 meter per second. Electric field is 2 volts per micrometer, okay. So I can write it as uh, 10 into 10 cube upon 2 into meter per second. This is drift velocity, and this is volt per micrometer. So it will be like 5000 into uh, micrometer square per volt per second. So here the answer will be second option, right? No need to convert the micrometer into meter. Now next question is, the intrinsic Fermi level does not lie exactly at the middle of the energy band gap. Which of the following is a correct explanation for the following statement? First, see, first of all, what is the concept for an intrinsic semiconductor? For an intrinsic semiconductor which is absolutely pure in nature, electrons and holes are generated in pairs, right? So concentration of electrons is equal to concentration of holes, right? So Ni, this is intrinsic carrier concentration, this is equal to Nc e to the power minus Ec minus Ef, okay, upon Kt. Now this is hole, Pi, this is equal to NV e to the power minus EF minus EV by KT. Okay, so after equating the both, NC e to the power minus EC minus EF upon KT is equal to NV e to the power minus this is EF minus EV by KT. So following this, what we get? We get as NC upon NV e to the power minus, this will be like this way, EC minus EF by KT divided by, it will be e to the power minus EF minus EV upon KT is equal to 1. Okay, now this will be NC upon NV e to the power minus EC plus EF and then plus EF and minus EV, okay, divide by KT is equal to 1. So taking log on both sides, by taking log on both sides, we have ln uh, NC upon NV plus minus EC plus twice EF minus EV upon KT equal to 0. Okay, so you have what, when you are going to solve it, you have KT ln N C upon NV. Okay, this is carrier concentration. Okay, effective carrier density NC by NV. Okay, and this is equal to EC plus EV and minus twice EF. Right, now what will happen? This EF is equal to EC plus EF. EF is equal to EC plus EF. Sorry, EC plus EV by 2 and then minus half of KT ln NC upon NV. So this NC is equal to 2 into 2 pi m n KT upon h square of whole to the power 3 by 2. Okay, and then NV is equal to 2 into 2 pi MP KT by h square to the power 3 by 2. So this is the formula. Now what are given in the options? You have given the effective density of states at the conduction band edge is not equal to the effective density of states at the valence band edge. So this is true. Yes, it is not equal to that much. The effective mass of electrons not equal to the effective mass of the holes, because it is asking which of the following is the correct explanation. If the intrinsic Fermi level does not lie exactly, it means if EI does not lie exactly at the middle of the energy band gap, if this is your EV, this is your EC, so this does not lie in the middle of the gap, then what will happen? This NC will not be equal to NV and the effective mass of electrons will not be equal to the effective mass of holes, as you can see. Okay, so what I have calculated here, NC, what I have calculated here, NC and NV. Okay, so the effective mass of an electron is less than that of the hole, so that NV is greater than NC and it affects the position of the intrinsic Fermi level. If you can see here the two formulas, NC is equal to 2 into 2 pi mnkt by h square of 4 to the power 3 by 2, and this is 2 into 2 pi mpkt by h square to the power 3 by 2. So because the effective mass of electrons is less than that of the hole, so NV will always be greater than NC. So it affects the position of Fermi level. Okay, right? Now your next question is third question. Third question says a p-type semiconductor is in thermal equilibrium and has a hole concentration of 10 to the power 18 per centimeter cube and an intrinsic carrier concentration of this much. The minority carrier lifetime is this much. The change in the recombination rate of electrons if an excess electron concentration of this much exists is C. Without excess, okay, without excess carrier concentration, we have what? You know the formula that N naught P naught is equal to Ni square, right? So we have n naught is equal to ni square by p naught. So this is what ni is, how much it is, 10 to the power 10 का whole square by p naught. Okay, so here p naught is 10 to the power 18. 10 to the power 18. Okay, so what you will get here, 10 square per centimeter cube. Now what you have Rn naught. Okay, Rn naught, this is equal to how much? The minority carrier lifetime, it is t tau p. Okay, and this is what n naught. So this is equal to 10 square by minority carrier lifetime is 2 into 10 to the power minus 7. So this will come out to be as 5 into 10 to the power 8 per centimeter cube per second. Now this was all without excess carrier concentration. Now with excess carrier concentration, we have Rn is equal to how much? With excess carrier concentration, we have Rn, because we have given if an excess electron concentration of delta n. So with excess carrier concentration, we have Rn is equal to delta n upon tau p. So we have what? 10 to the power 12 by 2 into 10 to the power minus 7. So this comes out to be as 5 into 10 to the power 18 per centimeter cube per second. So that means delta R is equal to Rn minus Rn naught. That means Rn is how much? 5 into 10 to the power 18 and minus 10 to the power 8 per centimeter cube per second. So this will come out to be as 5 into 10 to the power 18 per centimeter cube per second. So the answer comes out to be as third option, because you should know what is R and not. You should be knowing that what it is asking, change in the recombination rate. That means change in the recombination rate is delta R, and this is equal to Rn minus Rn naught. Rn naught is what? Rn naught is the recombination rate of electrons, and this is equal to what? Rn naught is equal to n naught upon tau tau n naught. This is the formula. N naught means carrier concentration of electrons by minority carrier lifetime. Okay, so I have taught you 3 questions. Just practice it carefully. Okay, till then please like, share and subscribe, and thank you very much.